See the book in the description for the proper definitions I use. In current physics, we have no complete machinery for reality. We have never gone beyond our or the scientific perspective, and have to rely on the symmetries of reality to describe, explain, understand and believe as best as we can. To do so we need constants, but we do not explain why they exist. In this video, the most important constants will be explained from underlying complete machinery. The constants are the speed of light c, Planck's constant h, the gravitational constant g, the elementary charge E, and the masses of elementary particles. To explain these constants, we will only be able to use the properties of space-time capital, because space-time capital is all there is. This is an absolute restriction. If it cannot be done, we cannot model our reality with the fabric of space-time capital. These properties of space-time capital are the deformability, the elasticity and the elastic resistance of the fabric of space-time capital. We have to realize that elasticity and resistance do not necessarily have to be constant, just constant enough, within at least the realm of our current measurement capabilities in space and time. For instance, the speed of light has never been measured outside our solar system or 1,000,000 years ago. The speed of light is today a defined number instead of a measured number. It is just assumed constant because for the moment that is more than sufficient for our needs. Let's begin with explaining the speed of light because it follows directly from the deformability, elasticity and elastic resistance of the fabric. The deformability ensures the possibility of reshaping flat space. The elasticity ensures movement. The resistance ensures a specific speed of propagation in the fabric. The stiffer the fabric, the higher the speed of light. A specific speed of light belongs to a specific resistance of the elastic fabric. Now let's take a look at Planck's constant. There is a scale of things. Elementary particles have certain masses, atoms have a certain size, energies are quantized. The scale of things comes from the variability of elastic resistance of space-time capital. The more space-time capital is bent, the stiffer it becomes. This variable elastic resistance, this stiffness of the fabric, puts sort of a limit on the bendability of the fabric, given that the amount of energy in the fabric is finite. You cannot keep on bending some fabric arbitrarily more than it already is. This limit on the bendability of the fabric of space-time capital sets a limit on the size of the smallest deformations. The RCB, or resonance carrier ball, has a certain minimum radius. It cannot become smaller. Photons have a certain maximum in the product of frequency and amplitude. Planck's constant comes from this bendability limit and relates to the scale of things that we experience. The mass of elementary particles comes from the complexity of the structure that space-time capital locally has. An amount of fabric is rolled up into a certain volume. This fabric is pulled from its environment. So again, the properties of deformability, elasticity and variable resistance combine to shape local complex structure that is not capable of traveling at the speed of light anymore. The charge of particles comes from the possibility of mirror symmetry and resonances in shapings of space-time capital. How exactly space-time capital is shaped and changing to create charge is to be discovered in the future. The gravitational constant results from the three properties of spacetime capital in a more indirect way. The scale of things is determined by the limitation on deformability, resulting in a specific minimum size of the RCB and specific maximum size of resonances in this local structure. The complexity of a specific structure requires a certain amount of fabric. So the complexity of the deformation determines the amount of fabric attracted into the structure. The stiffness of space around the structure determines how space capital in the neighborhood of the structure is attracted to the structure, and what radial relation between stretch and distance arises. This in turn relates to general relativity and the role the gravitational constant plays in it. So there it is, the story of how the three properties of spacetime capital can lead to the discussed 5 elementary constants. It's up to a numeric experiment to determine if and how these 3 properties can really do the trick. We have to find structures for fermions and bosons and do all kinds of constructions of numeric experiments to see if we can determine the links between the properties of the fabric and the resulting properties of the human and scientific perspective.